everyone. Thanks for joining us today for the Getting Ready for the Total Solar Eclipse webinar with Dave Vernier and Noose. I'm going to go through a few housekeeping items while we're waiting for attendees to join us. We are recording this session, so that link will be shared with everyone after the webinar is done. And you'll also get access to, and I'll put it in the chat, to a shared folder that has some resources for you. One is a PDF document that Dave put together with a bunch of Eclipse information, and then you'll also find your certificate of attendance for attending today's webinar in there. We would love to answer your questions throughout the session today, and I know many of you had included them in your registration form, so we'll do our best to get through everyone's. If we happen to not get to yours, we will follow up with you. So feel free to use the chat and let us know where you are joining us from. And if you're going to be lucky enough to be in the path of totality, we'd love to hear that too. With that, oh, and the most important thing I almost forgot is one lucky winner of who attends our webinar today will receive a teacher pack of Vernier Eclipse classes. So we'll be selecting that winner before the session ends today. So more on that later. And with that, I will pass it on to Dave and Noose.
Hello, everybody. I'm Dave, and I have this small image. I think right now I make the joke that at my age it's nice to keep the image small. I'm glad to do this. I'm a real promoter of seeing eclipses. I've been lucky enough to see 3. I saw one back in near Oregon in 78, I think it was, 79, and then I went to Australia once to see one. And then I had the wonderful chance to see an absolutely clear sky eclipse here in October last 2017, and an awful lot of people in this office saw that eclipse, and we just had a great time. So I'm a big promoter of eclipses, especially. My number one message is if you possibly can get into totality, do it. It's just a wonderful experience. And don't forget that the next total eclipse in North America is 20 years away. So it's not like you're going to have a lot of chances unless you're willing to travel a lot. So anyway, we'll go through some things here. Noose is going to Maryland, I think he said. I'm going to go to Ohio, which is in totality. I'm a little worried about the weather, but I'll be collecting data. And if some of you collect some interesting data, please send it to me, dvernier@vernier.com, and we might throw together a website or something like that. I'll tell you what happened in 2017. I was really excited about the eclipse, and I really worked hard getting people to get out there and see it and take data. It ended up being an article in Physics Teacher magazine. And it's got, in that article, I posted a lot of data taken mostly by other people, some by me, but not very much. And basically, you have most of that data. The back part of the article that Angie has put in, I guess it's in the chat. Is that right, Angie? Or is it attached or something? Anyway.
I am putting it in there momentarily.
Okay, there's a document, I think it's about 30 pages or something like that, but much of it is the data from the 2017 eclipse, which will be useful because if you're going to go do some data collection, you can look at what people got back then and get some idea what kind of time scale and what kind of numbers you might expect. So we'll talk a lot about that toward the end of this, the conversation. Okay. So of course, I got to say, I said my number one tip was get into totality if you possibly can. But I guess I really should say my 0 tip is don't look at the sun. And of course, if you're a teacher, you want to be extra careful about getting that message to your students. I think everyone knows about eclipse glasses. I was wearing these goofy things. These are ones we actually sold. We were out of them, but we now have about 6 or 7 packs of them. If anybody wants them, you might call us. I wouldn't place an order by mail or anything, it'd be too slow. But if we sell them for 50 for $25. And my wife said there's a few packs left that we kind of forgot about. And of course, somebody in this group is going to get some in a drawing. So you know that you should you can look at the sun through these things, and you should, those of you who are going to be in the partial eclipse, that's all you should ever do, looking at the sun, unless you use some system that I'm going to show here in a minute. If you're in totality, you can briefly take the glasses off and look at the sun, but only in totality, and you'll know when that is. It's very dark. If you're ever wondering if your eclipse glasses are safe, they should have CE markings, or ISO is another marking some of them have. Another way to test them is if you have fluorescent lights, just look at fluorescent lights and you should see absolutely no light getting through. So I guess those are my two main warning and tip things. I'm going to say then first a few things about this particular eclipse. This is the map. Can you see that okay? I know it's small. This is a great map showing the path of the eclipse, starting down here in Mexico, going up to really Greenland almost, Nova Scotia at least. The map has some interesting things. The yellow part is totality, and that's what my message was. Whatever if you possibly can get into totality, do it. There's a person in this office who uses the line, well, first of all, the difference between a partial eclipse and a total eclipse is day and night is certainly a true statement. The one guy here uses the analogy of seeing a partial eclipse is like driving your family to Disneyland, pulling in the parking lot, and then going home. It's just not the same thing. Really encourage you to get into totality. Let's see, for example, if you lived in Toronto, Canada, you're just outside. Don't stay there. Get here. If you live in St. Louis, do whatever you can to get yourself into this totality because it will be a memorable experience. And there's some special things that make this eclipse super exciting. One is we're in a peak of solar energy, solar cycle. The sun's energy goes through, I think, an 11-year cycle or something like that. And last time we were not nearly the peak, and now we are. So there's the corona is going to be, we think, much more likely, and there might be solar flares. That could be really exciting. You've got to be in totality to see those. Another thing is the moon is a little bit closer to the sun, so the eclipse will, in general, be a little bit longer. And I think this is exciting. I don't know if it's really going to work, but there's a comet out there. It's called officially 12P/Pons-Brooks, and some people call it the Devil Comet. And it might be visible in totality, which would be extra cool. Just mention some things that could be really great about this eclipse. On the negative side, I will just say that it's April, and I know I'm going to be in Ohio, and the odds, they say, the Scientific American here, this one here, has the March issue, has a graph here showing the probability of clear skies, and frankly, they're not great. Down in Mexico, they're pretty good, but they decrease all the way up. I think in Ohio, it's a 40% chance of clear skies. So I think you have to realize that the odds of clear skies are not really great, but you've got to do the best we can. It'll certainly get dark in totality, and that'll be interesting. I've never been in an eclipse where the skies weren't clear, so I guess that would be an experience anyway. The other negative is, it's really kind of a interesting one. So many people saw that eclipse in 2017 and got excited about eclipses that I think we are going to have a tremendous interest in this eclipse, and people are going to flock in. I think there's, out of our office, I know 3 or 4 or 5 people are flying all the way to the East Coast to see this eclipse. And I bet that kind of thing is going on around the world. And I think we'll have some of the most monumental traffic jams in American history. And that's just a fact of life. And if you're going to be there, it's worth it, but be prepared. When we had the 2017 eclipse, I knew traffic would be bad. I went about 1 hour south from Portland, And my wife and I took extra food and water, and we took a movie. We thought we could just pull off the side of the road and watch a movie, let traffic die down. We did that. It wasn't enough. We should have taken 3 movies because it took about 10 hours to get home after what normally would be a 1-hour trip. So I guess I warn you about that, but don't let that discourage you. When you get home, you'll finally say, well, it was worth it. So anyway, I said before, don't look at the sun directly except through in totality or through these things, but I want to show some other alternatives. Oh, let me do one other thing first. Here's a fun thing that you can do. I mentioned this in the paper. It's a way to find out what the eclipse will look like where you are. This thing here, I think it's called the Eclipse 2024 is the website. The fun part about this is you can type in any place you want. Type in the name of your city right there. I typed in Xenia for Xenia, Ohio, which is roughly where I'm going to go. If you do that and click on this thing, it does an amazing thing, I think. It will generate a simulation of what you will see. And notice it's giving the exact time that it'll start. It started about 1:55. And now it's going through, and you can see it also lists here. Notice the altitude of the sun and the azimuth. 180 would be straight south, so that's a little bit west of straight south. So you know where to look. That's helpful because when you go to find a place to sit, so you want to get a good spot for watching the totality, you got to know where you're going to be looking. And also, you want to know how high in the sky. It's going to be 55.7 degrees. The other thing to notice from this is the eclipses are slow. Remember I said it started at 1:55. I'm going to speed this up now. 1:55 start, 3:10 totality, 3:12 it's over. The totality is over, and now I go out to after 4 o'clock. It's over. So remember, the whole eclipse, starting with the partial stuff, is about 2.5 hours long. And where I am, I have only about 2 minutes of totality. That's because I'm not at the center, near the center line. Maybe I should move further in toward the center line. We might do that. But what's the message here? The eclipse will take a long time, and you're gonna either be tired of wearing these goofy glasses and putting up, or you can do something with a projection system, and I'll show you a couple possibilities. The most popular one is a pinhole camera. And the way you make it is take a box, cut a hole in cardboard, and then put aluminum foil there and just poke a little tiny pinhole in the aluminum foil. I did it with this pin right here. And then you put paper at the other end of the box. If you take this thing out in the sun and point the aluminum foil end up at the sun, you get a very small but true looking image of the sun. The great thing about that is that can sit there for the 2 hours and anyone can look at it. They don't have to put their glasses on. They just look into the box and see that image. So it's worth doing. It's very easy to do. Here's a tip I picked up at the recent NSTA meeting. This is from a group. I have the link for how to make a pinhole cameras on the handout, and so there's a link to this thing. This is they take cheap glasses that people have for readers, and they break them, and they put one of the lenses at the end of a cup, put a fairly big hole in the end of the cup, and then project that down at the sun. There's a picture in the handout showing how to do this. I tried it today. We finally had some sun in Oregon, and I could try it. And the image is bigger than on the pinhole camera, and that might be worth doing. So some things to think about there. In the similar spirit, while I'm talking about that, people often talk about, let me put that camera back on. Consider taking something like this with you to the eclipse. Because when you're in the partial phase, let's say you've got a nice crescent-shaped sun. Each of these little holes in something like a colander will act like a pinhole, and you get interesting patterns projected on the ground. In the same spirit, if you are around trees, sometimes you'll get really cool patterns because the leaves of the trees act like little pinholes and make an interesting pattern on the ground. Okay, so some other tips about totality. I said to research where you're going to be. Another thing to research is the planets. I've done a little work on that, and I think what you're going to find, at least where I was, Jupiter is going to be to the west, and it should be about 48 degrees high, so it should be very easy to see. But you know, it's not that easy to tell planets from good bright stars. So it's not, some of you, if you don't know your planets well, I really encourage you to use some little inexpensive app or something to look up where the planets will be at the exact location where you'll be at the exact time. I use one called Planets. It's on iOS and it's free. And it just, you put in the latitude, longitude, and the time, and it shows a picture of the sky and you can see where the planets are. So I fully intend to look for Jupiter to the west. And there's also some sliver of a chance that I might see Venus, but it's real, real low in the sky, and I think you'll have the same problem. And then don't forget that comet that I mentioned before. Anyway, another thing I would say is watch for weird animal activity. It's really kind of amazing that animals get excited about this unusual change in lighting. Bees and birds and all bats are supposed to sometimes come out, so be ready for that. And maybe that's a good reason. Another thing to think about when you're selecting your site where you go. Maybe you want some animals around or some chance of that. Also, avoid being in a place where there might be automatic lights. Wouldn't it be a bummer if you're waiting around all this time for totality and then all of a sudden totality comes and some light right above you comes on and ruins the whole thing? So watch out for that. This day and age, so many things are controlled automatically by a sensor or something. So watch out for that. And I thought this was humorous. I've done a lot of research on this stuff. The New York Times has a tip for fashion. They suggest, here's a quote. They said you should wear green clothes or contrasting combination of greens and reds because the Punchunchi effect, I have this in the handout, as the sky darkens, light sensitive cells of the human eye become more sensitive to shorter wavelength light and you'll look better. So there you are. Okay, so I'll say a word or two about photography. The question always comes up about photography. Remember, the partial eclipse goes on for hours, an hour at least each way. But the total eclipse, if you're very, very lucky, it might be as four or so minutes. You're going to be very excited. You're going to be nervous. It's dark. And I really think you're making a big mistake if you fumble around with the camera and that's all you do for the time. So I would encourage you to consider that there's professional photographers who have equipment that probably costs about 100 times more than yours does. And they're going to post those pictures the same day as the eclipse happens. So I wonder if it's worth it. It might be fun and try it, but don't spoil the whole thing by feeling like you've got to take a whole lot of pictures. I'm going to show a goofy film here. I've said that when they had the 2017 eclipse, I said those words to my family. And I was absolutely surprised that one of them actually listened to me and did this idea. And that is to take a movie camera, and you can use a cell phone these days, put it on a tripod and don't point it at the sun, point it at the people watching the eclipse. And I think you'll find that's kind of fun. In fact, I'm going to show this movie. And why am I showing this movie? Because I think it'll show you how excited people get about eclipses. So this is just out in a field in Oregon. We had lovely weather, and this is that 2017 eclipse. So I'll just start showing this. This is approaching totality. One thing, camera lenses are amazing. The fact that that camera can handle that incredible change in brightness is amazing to me, but it does. Anyway, I'm going to skip ahead, but and as we'll come to the point where this was about 3 minutes of totality, but let's go ahead here. I think I go to 2. Now we're getting toward the end of totality.
The universe is happening so hard right
And we even have some unusual animal behavior here. Okay, anyway. My message here is that you really should try to get in totality and consider that as something to do on the photography side, which is not much work in this day and age with cameras built into every phone. So the rest of the talk, I think I want to talk about taking data. As I mentioned before, we did a lot of this, and lots of people did a lot of this in 2017. And I think we can do a better job this time. I've learned some things. Skipping ahead in this document. We saw that some questions came in before the session started. One question was, what's the best one sensor to use if you want to use just one sensor? I would say two are in the running. One is temperature. So let's talk about temperature changes. We have lots of temperature sensors. I'll show some. Get rid of some of this other stuff. Basically, in the old days, we had long ago, we had our stainless steel temperature sensor, and we had our surface temperature sensor. Both of these are wired, and they plug into something like a LabQuest or a LabQuest Mini, or in the old days, a Lab Pro. Now we have the Bluetooth versions. This is a GDX Go Direct Temperature Pro, and this is a Go Direct Surface Temperature Pro. So again, what's the difference between these two? The electronics is exactly the same. The difference is this one has the surface one has the thermistor temperature sensor. Maybe it's a thermistor in that case. I think it's not a thermistor here. The net effect is this temperature sensing unit is totally exposed here and totally protected here. That's good. The protection's good in those cases because you can stick this thing in chemicals and not have to worry about it. But it also slows down the response. So if you're going to do studies of air temperature, the surface one is slightly better. I don't think it's like you can't use the stainless steel one, but I'll show you the effect. If we go to the article here, let's skip ahead to the actual results. This is the part where this is taken from the physics teacher magazine. So here's a fellow in I guess he was in Missouri, and he took temperature readings. Now we can tell where the totality of the eclipse was because this is brightness, this is illumination. So we know totality was right here, and you notice that the temperature minimum was a little bit later. Now it could be that's real. I don't know, but he did use a stainless steel. It says right there, temperature probe. So it might be that it was just a case of before the temperature change got to the actual sensing unit, there was a lag. So I would encourage you to consider the exposed temperature sensor versus the stainless steel. Now, another possibility is that might be real. Maybe there is a lag effect. Just like the hottest day of the summer is not usually end of June. There's a lag, right? That things take a while to happen. Maybe that's the way it is. So the temperature is interesting. I think you can look at the temperature change here. We had, what's that? This person, it looks like they had some weather, but just looking at from here, we went from 45 to almost 33. So that's more than 10 degrees Celsius. Those are Celsius degrees, a lot bigger than Fahrenheit degrees. Let's see if I think there's another one here somewhere. Here's a temperature change. This person had a lot of weather, but look at the temperature change just in the region around totality. A good, I'd say a good 10 degrees, maybe. So you can really get some interesting temperature changes, and I hope you'll try that. One important tip, the standard way to measure temperature is to have the temperature sensor in the shade in a well-ventilated area. It's not proper. When you get reported temperatures from weather stations, they have to be in the shade. So take some kind of box or something and cover your probe, but make sure there's cuts in it so the air can flow in and out. Or else it's a kind of a bogus temperature read. The other next most interesting thing to study, I'd say, is the various kinds of light. And there's a whole lot of different kinds of light in the electromagnetic spectrum, everything from infrared. We don't really have a good infrared sensor exactly, and then all the three colors, the red, or the 8 colors, what you call it, of the visible spectrum. And then there's UV. Now, all those can be studied, and I have examples of those in the handout. Let me show you some sensors. In the old days, we've had this sensor here. We still sell it, called a light sensor, and these are a sensor. This is a sensor that measures illuminance, which is a measure of light as perceived by a human eye. So we did a whole lot of work to make sure this records light, not in terms of how much energy is being put down there, but in terms of how your eye perceives it. So the filtering is to make it match the eye's response. Illuminance, we call that. And then we also have UV sensors. This is a UVB. We have a UVA. And both of those are interesting. And, I think it might be fun to see, they drop off at different rates. And how does the rate at which the illuminance drops off compared to the way the UV drops off? Now, we've got lots of sample data here. Let's look at some. Okay, I took this data actually in Oregon. Luminance is brightness is perceived by the human eye, and then here's UVA and UVB. And you'll see they're very similar, but there are some subtle differences. Like, for example, notice that the UVB is a lot higher after. Why is that? Well, because our eclipse was at 10 in the morning, and so by the time remember, it's an hour or so of partial. So now we're getting up toward noon, and the higher the sun is, the more UV there is. That's why they tell you to be so careful around noon about getting sunburned, right? So I think it doesn't show up much on the illuminance, but it sure shows up on the UVB and the UVA. With these things, with all those sensors, with the illuminance and with the UV sensor, there's an issue that comes up, and Anus was just asking me about it today, and I don't know if I have a great answer, but here's that question. If you're going to measure, the brightness in the eclipse, what should you do? Because the sun moves, right? Here's one option. Make a rig like this. Whoops, let me get her down. So turn this up. Make a rig like this and point it toward the sun, and then track the sun gradually. It's going to move on you. You're going to have it 2 hours or so. And what do? Every 5 minutes, move the thing. That's one option. And another option is take this thing and put piece of white paper on the ground and point this thing right down at the white paper, a bigger piece of white paper. Now that's got some simplicity advantages. You just, you're getting reflected light, but it probably is a meaningful way to get some measure of brightness. And you might experiment with it, which one of those you want to try. So that's an issue that comes up all the time. And I've done it both ways, frankly. I'd say whatever you do, document what you did so you can tell other people what you did. And then if you're going to compare apples to apples, you can compare that way. And next, I want to mention a sensor that unfortunately is expensive, but it kind of works around that problem. This is called a pyranometer. And we've had them for years. We have two kinds now. I'll bring them over in the camera. This is the older one. The pyranometer it's designed specially to be sensitive to all wavelengths of light, electromagnetic radiation. And the nice thing about it is it just sits there. Oops, you can't see it. Let me move this thing. It just sits there. It's like a little dome. And it's designed to just sit there, and its lens on the top can handle the sun's position change. You don't have to do a darn thing. Now, that's good. And it measures the total energy in watts per square meter. So if that's what you want to study, that's a good way to study it. We have now a Go Direct version of that. That's this one here. Same thing. And again, you don't have to point it. You just let it sit there, point it straight up, and the problem's handled for you. The bad news is the darn things are expensive because they're so carefully calibrated and all that stuff. So there's some light things to measure. I want to mention now two new sensors that we didn't have last time in 2017. Both of these I'm going to be using in Ohio. This one, our Go Direct light and color sensor, it has some really nice advantages. I think I can actually connect to this and show you it in action. Let's see if this works. This is our program called graphical analysis. Is that working? You got Noose, is that okay? Can you see the program I mean?
It looks good to me, Dave.
Okay, I'm going to show the channels. So it's a light sensor, but it's more than a light sensor. It's plain old light. That would be what I call the luminance, the total amount of brightness. It also has a UV/blue sensor. It has a red, green, and blue sensor, and you can turn any one of those on and take readings, and you can do all of them at the same time. So I think that's going to be exciting to try during the eclipse, and we can look at how they vary. Now, I haven't had a chance to do this. The nearest thing to it, I'm making another Oregon joke, but I've been waiting for days to get some sun so I could try that, an experiment. I'm not going to have an eclipse, but I thought I could at least go out and do the sunset. So I finally got a day that was reasonably clear. And here with me using that sensor to study a sunset. So there's the red, green, blue. And I don't know if this shows anything, but I think maybe you could argue that here it wasn't that, it was pretty cloudy, so it wasn't all that sunny, but the best I could do. Remember, it's Oregon. You'll see that the red is like half the blue versus here, you could argue it's more than, especially the red compared to green. The red was maybe 2/3 of the green, but here they're virtually the same. So I think you could argue that red has increased in intensity compared to green at least. And that's why we maybe see the sunsets red. Or here's a question to investigate. Is it really that we say sunsets are red? That doesn't seem to jive with that New York Times article thing that said your eyes are more sensitive to blue when the light level goes low. So I think I'm not clear on what all this means, so we could investigate it. And here's another new sensor that I'm excited about. I think this will lead to some interesting stuff. This is our weather station. And I've got it mounted with a weather vane on a tripod so it can handle wind speed, wind direction, and it's got lots of other channels. Let me show those to you. I'll turn it on and I'll go back to that graphing program that's graphical analysis. Oops, I think I started a second copy. I don't want to do that. Oh, I don't want to do that either. I want to do that. Okay, here we'll do it right. Sensor data collection. There's the weather station. And you'll see there's lots of channels. So I can get wind speed, wind direction, temperature. Hey, there you go. And how about this? Any chance the relative humidity is going to change in an eclipse? Oops, maybe. And how about pressure? Is there any chance that the pressure is going to change? I think all those things would be interesting to investigate, and I will do that. I encourage you to consider check it. Wind direction is interesting. I think it might be well true that that eclipses do create a little bit of weather themselves, and you might get some wind shift. So I guess I'll mention two other things you might consider measuring. One is spectrophotometers. Get the camera back on. This is our SpectroVis Plus, and it normally is used for absorption experiments, but you can put this fiber optics thing in, and then you can measure emission spectra. So you could point this down. Do you point it at the sun or do you point it straight up in the sky? You have to think a little bit about that. And you could get a spectrum of the light emitted by the sun and see if that changes. I'm not going to promote that vigorously because, first of all, the SpectroVis are a little more expensive. And secondly, it's not a calibrated reading. We don't say that in emission that, a 10% change in the red reading means a 10% change in the amount of red light. We don't know that. It's not calibrated in that sense. But that's something you could do if you happen to have SpectroVis Plus in that fiber optics. So some people, I'm sure, will be doing that. And another one that I think you might be lucky enough to be able to do, especially now, let me show you this idea. Even if you're not in totality, you might have a bunch of solar panels that it would be interesting to see what happens with them on the day of the eclipse. We were in the last eclipse. Our office is in Beaverton, Oregon, and we were about I thought I said here. About 99% totality, not completely there. But I couldn't read the solar panels. They're mounted on the building, so I left them where they were. But I did take data, and this is the day of the eclipse. And you see that neat little dip just for a few minutes. And then here's the next day, which happened to be similar weather. So I did it just to show the pattern. So, and remember, this is not in totality. And I guess someone had written in a question about, even if you're not in totality, can you get interesting data? And I would say definitely, yeah. That's one example. Here's another one. This is a fellow who was in a 74% totality in California during the 2017 eclipse. And you see he got a drop in luminance, which is brightness as it's perceived by the sun, about maybe 2/3 drop or something like that. So you can definitely get good data. You don't absolutely have to be in totality. I think I'm going to shut up and see if people have questions. Or Noose, if you want to jump in and say anything.
No, there were some cool suggestions though, and I thought that was neat. But one question was, where are you guys going to be in Ohio?
Well, around Dayton, Xenia area, we haven't quite pinned it down. And it's totality, but the weather is the big if there.
Yeah. There was also some discussion about looking at indirect light, like reflected light versus directly looking at the sun, or the moon, I guess, whatever. And what was the better way to do it? I'm thinking of pointing the light sensor down, the Go Direct light sensor down, but will that minimize the amount of UVA and UVB I see?
That's
Will
the
it
thing on UV, I don't know how that works. UV scatters a lot, so it might be better just to point it like straight up and just get the scattered UV. I just don't know the best answer on that.
Yeah.
So one thing to keep in mind, it might be, and this is, I haven't researched this. If you point the certain light sensors straight at the sun, they might peg out. That is
Yeah.
exceed their maximum reading. Then that's useless. So check that. Oh, and this is a major point. I should have mentioned this earlier. Let me say this, and please listen to this tip. Practice, practice, practice. If you're going to take data during this eclipse, you're going to be nervous, especially if you're in totality. You're going to blow it, frankly, unless you've practiced. So remember, the day before the eclipse, the sun will be in almost exactly the same position. You can go out there and take practice data and get used to the routine. Have your tripod set up or whatever you're going to have your computer set up, do all the stuff to have a good dry run so you can, make sure you do it right the day of the eclipse, when you naturally are nervous and you might well just forget to do something. So I think it's a real key point.
So I've got a question.
Yep.
I'm looking at Clarence's data there that you're showing on the screen. Looks like it's running for 60 to 80 minutes. How frequently should we set the data collection up for data collection?
That's a good question. I would say he wasn't in totality, right? So for him, it probably didn't matter as much because he didn't get a real drastic quick change. But if you're in totality, the drop is pretty, maybe more quicker. That one little period, I can't zoom in on that right now, but I would say, if you're in, remember, totality is only 3, maybe 4 minutes at most. So you want to get a bunch of points but on the other hand, the whole thing goes on for 2 hours, so you don't want too many points. So some compromise in there, maybe once every 10 seconds, something like that.
Okay. Yeah, I was just thinking and I'll play around with it too. While I'm still here, but yeah, then how many, let's see, in 2017, I did once every 5 seconds. It's what Eric, some of that data that you're showing is Eric's data. And he said he had once every 5 seconds, but boy, that could end up being a lot of data.
Yeah, but modern computers can handle a lot of data.
But,
So,
yep.
let's see if any other questions. All right, how about the chat? Anything happening in the chat there, Angie?
But that's what I've been watching, because I've been watching the chat. Let's look at that document that Angie shared with us earlier and see if there's anything that we didn't answer. Oh yeah. How far into the future do you know when
Yeah.
So according to a website I found, the question was, how far into the future do we know when these types of eclipses will occur? Well, I did a little quick and dirty Google research, and this was from space.com. So I don't know how, good that is, but I mean, I want to hope that's reputable. They say that they will have total eclipses for about 600 million years. I don't know what that means. It's an awfully long time. Sound sensor. What do you expect, Ellen? What are you expecting to get with the sound sensor?
I assume the person's looking for animal sounds, and that could be interesting. I've heard about crickets stopping, chirping, and I've heard about bats coming out. They don't make much noise, but it might be interesting.
She says she's looking to get a lot of oohs and ahs.
Yeah.
That's cool.
That's why I showed that goofy movie, because I think it does show the excitement level. So
Yeah.
we had one person ask here about, see, I lost the question. Well, I think we answered it really about it not being a totality. Can you get good data? Yeah, definitely. And, a person mentioned the PAR sensor. That stands for photosynthetically active radiation. It's an interesting sensor. It's much like a PAR sensor, pyranometer, sorry, much like a pyranometer. That is you can just set it and have it pointing straight up and it just sits there. And it reads, it's much like a pyranometer reading, except only reading the part of the electromagnetic spectrum that plants use the most. So it would be a different kind of measurement. But I believe it's the reds and the blues more than the yellows in the middle of the spectrum. So I don't know how interesting that would be because frankly, eclipses don't happen that often. So it's not like they have a huge impact on plant life on the planet or anything. But you could do that and you wouldn't have to worry about the rotation or tracking the sun's movement.
Mary Kate from Chicago is laughing at the discussion about animals.
And I guess I would say, remember that if we have the old sensors, they should work just fine, and you can use graphical analysis. You don't, which you can take a LabQuest Mini. LabQuest Minis don't take power, so if you take a LabQuest Mini with a good charged computer battery, you can probably make it through the 2 hours or so of the eclipse. I think none of these sensors draw a tremendous amount of current. Like CO2 sensors and oxygen sensors take at least CO2 takes a lot of energy, but I don't think we'll be using that. So I think if you had someone ask about batteries and not being around power, a well-charged computer used with a LabQuest Mini, there'd be a good chance of surviving. Or a LabQuest 3 or a LabQuest 2 might do the job. Which should do the job, and they have their own batteries. Any other questions there, News, or should we?
Not too many. There was something about just a comment that they plan to use a Mini with 3 sensors.
Yeah, that should be fine.
That should work well. And there was a question about should we record the entire 2 to 3 hours or just a few minutes before and after totality? My suggestion was go back to that simulator and see what the time will be for your area. And then that way you can kind of plan like how long you'll need to collect data for. I think it tells you, doesn't it? Like how long.
Yeah, let's right. And notice I want to show that it even does cities that aren't in totality. Portland is certainly not going to be in totality, but I can still do simulation. So at 10:36, that's all we get. But even this is kind of good to know because you can, if you're a person in a partial eclipse, at least you know what you're going to expect. And when it's going to be at its best, like 11:16, and it's over at 12:20 or so. So that lets you really help plan the thing.
Yeah, Rick Rutland says there's an app for that.
So finding the times.
Yeah, apparently there's an app.
Right, of course, I would argue this is also does them, right? Just
yeah.
And the links to all these things that I used are in that document that you have. I hope you got it.
And yeah, Angie shared earlier, she shared the link to that folder where the document is located. Let me see if I can go dig it out real quick here. Or Angie, if you could throw it in the chat, probably faster than me. That way everyone can grab it
right now.
Yeah. Is there a way to get the actual clock time On the X, yeah, unfortunately, not on graphical analysis. Or is it always relative time collecting data?
Right,
Yeah.
that's a good
Yeah.
point. And so that means get in the habit of noting exactly when you hit the start button. Or the collect button, I should say. That's a real key point, yeah.
What you could do is put an annotation in on the graph. When you start collecting data, just insert an annotation if you're using graphical analysis.
Right,
And then you just say, start at 10:35 or something
right.
like.
That's a great idea. And then it's built into the file, it'll always be there.
Yep.
So even if you save it, it's not like you wrote it down, you lose a piece of paper and forget it. So building it in is the right way to do it.
Not
I
as
will try to
pretty,
remember to do that.
yeah, not as pretty, but on a LabQuest 2 or 3, you could add a note to the data. It's on the very far right side, looks like a notepad, and you could type it in there and it would follow the data set, once you save it. So you could add a calculate column after collection if you note when it was started. I don't know how, I've never tried it. I don't know how graphical analysis will it won't, I don't think there's a format for time. So I'm
No.
not sure you'll be able to get it at something totally meaningful. Maybe time in decimal, but oh, there you go.
Yeah.
I've got mine here too. Wait a minute. I gotta match Dave. Of course, I can't see squat now. There we go. That's what's supposed to happen, right? Yep. So we're all set.
We've never done a good time access on our programs, and we will someday.
It is one of the, pardon me. It is one of the on the list of things to add to Graphical Analysis Pro, but I don't know when that'll be available. Comment was made. I'm sorry, I'm losing my voice. You talked, I lost my voice. Comment was made, put it into Excel or Sheets, and then you could do it there because you have time options with that. I see stop monitoring other items and view the times adjacent to totality through binoculars. Yeah. Oh, be careful. So with solar filters. Okay. Yeah.
One last tip I just thought of, for those of you like me, maybe that might be in bad weather, if you're in totality and weather's terrible, you might do some Googling around for sites that have live presentations, like in Mexico or Texas or somewhere like that, where it might be kind of a consolation prize. If your sky is cloudy, you can at least watch one of these websites that shows the scene happening, and I'd say think of that as a consolation prize. Well, should we wrap this up?
Well, I'm gonna jump in and announce our lucky winner of the teacher pack of Eclipse classes is Rennie Morris. So I will be reaching out to verify the address of where you'd like those sent. So we will be in touch. And
Great.
thanks everybody for joining us.